Okay, in chapter 3, let's talk about the structure of crystalline solids. So, how do atoms assemble to form solids? I want you to think about that. So, let's focus on metals. Since we have different type of materials, metals are easiest one to look at this crystalline structure. So, let's start with metals. And so before we talk about crystalline structure, we need to understand the energy and packing. So dense regular atom structure tend to have low energy. Why is that? So dense regular atomic structure tend to have low energy. So we can look at this energy and packing by drawing a diagram that shows you energy and R, it's on the horizontal direction, that represents the distance between atoms. So when we close, if the curve close to the horizontal axis, which means the energy is low. So in this case, this is our zero energy line. And when we packing atoms to form solids, if we have a random atoms atomic structure, and that will give us a little bit higher energy, packing energy. And let's say if we have this random atomic structure, the energy it's somewhere around here. That's the packing energy. And another case, if we have a dense packed regular packing, most of the metals are like this. They're dense regular packing. The atomic structure has a certain order like this. It's not a random structure. It has a certain pattern. If we have a structure like this, and the packing energy would be somewhere around here. So that value on this curve, it's the minimum energy that required to packing all the atoms. Remember, this line, it's energy. So if you have a dense packed structure, and there will be less energy involved. Okay, now let's move on to the next concept. What is crystalline? And This crystalline is a very important concept. It's kind of the fundamental to understand how atoms are packed together. So crystalline crystalline, what do we mean by crystalline? So its atoms are contained in a periodic array. Contained in a periodic array. Oh my. And so crystalline atoms are contained in a periodic array over large atomic distance. So it could be a very long range order on solidification. And a crystalline has repetitive 3D patterns. So that's a feature of crystalline structure. It has repetitive 3D patterns. And you will see crystalline materials in all metals. All the metals has their specific crystalline structure. But sometimes, but there are some exceptions. For example, a glassy alloys, but most of the metals you see in this class will be crystalline structure, crystalline solid materials. And next we have many ceramics. Ceramics could belong to crystalline materials. Has this crystalline structure, which means repetitive 3D patterns in space. And there's some polymers. They're crystalline materials too. Alright, so remember when we talk about crystalline solid materials, and most of the metals are crystalline materials, and many ceramics are, and some polymers are. Most of the polymers are actually it's called amorphous. Amorphous, excuse me. So amorphous means there's no crystalline. It's non-crystalline. So amorphous is the opposite of crystalline, and so materials they just don't crystallize, which means there's no crystallized structure, there's no repetitive 3D patterns, and you will find most of the polymers are amorphous. And you may have a question, if they don't have crystal structure, what structure do they have? And that's a good question. So when a material it's amorphous, it could have very complex structures, and there's a high cooling rate. And very high cooling rate. And usually it's greater than 10 to the 6 or 7 power Celsius per second for metals. So let's come back here. So we talked about two different types of solid material structures. One type of materials which is crystalline materials, and they have this repetitive structure. Another type of materials are amorphous, which means they do not crystallize, and most of the polymers are like this type of materials.